Hello and welcome. So, for the graph that we see here for a hyperbola, we're going to be writing the equation. Now, there's two kinds of equations. I've already written them off to the side here. We'll see one where you have the x minus h over a squared before the negative, the one where it'll essentially switch with the other term and be after the negative. Now, essentially, this determines whether or not you have a horizontal or a vertical orientation for your hyperbola. If your x is positive, that means it's going to be horizontal. If your y is positive, it'll be vertical. So where we see a vertical hyperbola, right, where it's going up and down, we're going to be using this equation. Alright, so if you have horizontal, you'll want to use the other equation there. Okay, so we are looking at vertical, so let's use that one. Okay, so first off, for any hyperbola, you got to know a few things. You got to know the center, you have to know your a and your b. That's the bare minimum you need for at least a graph here, okay? Or at least even writing the equation in with just information, you got to know that much. So the center is always h comma k. That's why we got to know it, because that'll be your h and your k inside the equation here. Well, the center we can see because that's going to be the intersection of the oblique asymptotes, which is that point right there, meaning that your center is at 5, 2. So that means that your h value is 5 and your k is 2. So right then and there we know that for our final equation, where we're going to be ending up as, that we will have y minus k, which we just said was 2, squared over whatever our b squared is, minus our x minus our h, which we just said was 5, squared over whatever we find our a squared to be, and then equals 1. Okay, so now we got to find our A and our B. Now this one's not too bad either. Alright, so remember, A is always the horizontal distance to either a vertex or a covertex. Now in this case, it's going to be a covertex because your hyperbola is vertical. Alright, and then B is going to be the vertical distance. Alright, so from center to vertex. Right, vertex is going to be the point, the turning point on your curves for the hyperbola. So that's a distance of 2. So that means your b value equals 2. If we were to square both of those, that means b squared is 4. So that means we have a 4 under our y minus 2 squared down there in our equation. Now we're just going to find the a. Now this one takes a little bit of work. So a covertex is essentially, if you were to graph the little box here, right, so go from your, let me not use that, let me use highlighter instead, it's a little easier to see. So if you go from your vertex, right, and then you essentially go until you hit the line on the right, go until you hit the line on the left, right? Same thing for the bottom curve, go to the right, go to the left. And now you'll notice that if you just connect these 2 points together, it forms a little box. And that is how you can easily find your covertex, or your covertices, I should say, right? Because they're on the same y value. When it's a vertical hyperbola, it'll be the same x value for a horizontal hyperbola. Okay, and then essentially it's just the same as the center, and then middle of the box, middle of the lines for the box. Okay, so that means that we have a distance of 3. That's your a value. So a equals 3. So if you have a equals 3, square both sides, that means a squared is 9. Ta-da! That's your equation. Okay, so big thing is just finding the center, a value, b value, done. Okay, alright, that's it. Thanks for watching.